Hello, hi friends. So today let's try to learn something which many students are curious of. Many students, this question arises to most of the students. Let us find out what it is and how it has to be solved. I will be showing you in some of the perspectives. There might be many perspectives, but I'll show you from the point of view of quantum mechanics. The thing is that we know that inside an atom there are electrons, protons and neutrons. So this is the nucleus and the electrons revolve around the nucleus. We all know that. And this nucleus, we can say it to be as positive in character, and the electrons revolves around it. So why does this electron having negative character and this nucleus having positive character does not attract each other and get fused into each other? Why is that so? There is a simple theory for that. There is obviously attraction for that, but this side there is also an opposite centrifugal force. Centrifugal force for which this electron it stays in its orbit and it revolves around. That means what to say? You can say it is balanced there. Obviously, it is attracted. But if there could not have been centrifugal force, in that scenario also, if these electrons come and get fused to the nucleus, what would happen? Or even it is possible or not? Let us find it. So in these things I want to explain you from the point of view of quantum mechanics with the help of Heisenberg uncertainty principle. So let's get started. So know from experimental data, the radius of the nucleus you can take is approximately about 10 to the power minus 15 meter. Hence, since we know that the radius of the nucleus is 10 to the power minus 15 meter, so if these electrons come and get fused to the nucleus, inside the nucleus, its radius should be less than that of this 10 to the power minus 15 meter. If it is more than that, then what would happen? Nucleus would get destroyed. Say for example, if your house is this much is small, and you bring the furniture of this much quantity, if you get it somehow inside your house will fall apart. This is the same case scenario, so it shouldn't exceed this. Now let us look according to Heisenberg uncertainty principle. So according to Heisenberg uncertainty principle, we know that we can take delta x or delta p equals to h by 4 pi. There are more explanations beyond that, but I'm just showing you directly. So here, according to that principle, in short, if we can know simultaneously, the measurement of these two physical variables, we cannot find it simultaneously. Here it is known as, you can take it as uncertainty in position, and this is the uncertainty in momentum. So the main thing is that according to Heisenberg uncertainty principle, if any matter, if we know the delta x, we don't know delta p, and if we know the delta p, we don't know delta x. And here h is the Planck's constant. Okay, and this Planck's constant value is 6.62 into 10 to the power minus 34 meter square kg by second. We also know again this delta p, it also can be written as m into delta v. And this is the case we are trying to find out the velocity of the electron, this electron. So we know that the electron has got mass, and its mass is 9.11 into 10 to the power minus 31 kg. So if we consider this as equation 1 and this as equation 2, so now substituting equation 2 in equation 1, what do we get? So let us again first write the equation 1 for your better understanding. I have written this again once. Now we will substitute it. So delta x is delta x, delta p we can write as this, h by 4 pi. Okay, now we know we want this v. So h by 4 pi delta x. So now we'll substitute the values. This value is 6.62 to 10 to the power minus 34 meter square kg by second, and it is 4 pi value we know that 3.14, and this delta x we have here, we have considered it as the radius of the nucleus, which we have I have written in the initially to be 10 to the power minus 50, and we know the mass of the electron, which is 9.11 into 10 to the power minus 31 kg. So now if we solve this 6.62 into 10 to the power minus 34, after solving this, I have done this solution before, so I know this, so I am doing directly meter per second. All upon there will be meter, so it get cancelled, it get meter per second, and last we get 5.78 into 10 to the power 10 meter per second. So we have found out to be the velocity of the electron, that is 5.78 to the 10 to the power 10 meter per second. So what surprises us here is that the fact the velocity of the electron we have found here is to be greater than the velocity of the light. So velocity of the light, it is 3 into 10 to the power 8 meter per second. So here we have found it more than the speed of the light, which is not possible. Since we know that any particle which has got mass, here electron it has got mass, we have substituted the value of mass, because it has got mass, and since it has got mass, it cannot move more than the speed of the light, but we find the answer which is more than the speed of the light, which is not possible. So this is also one of the reasons why electron also, if it gets fused, cannot exist in nucleus. And now if we try to look from another point of view, from energy point of view, so we know that energy is explained, we can write as E equals to mc square. We can also write as mc dot c, and this mc can also be written as, this is mass and the velocity, we can also write as delta p dot c, and here the value we get, it is greater than 10 MeV or equal to 10 MeV. So what does it show us? This shows that if an electron exists in the nucleus, the energy, it must be at least 10 MeV. But however, from experimental data, it indicates something different. It indicates that an atom can never have energy, greater than 4 MeV. So hence, electron do not exist in the nucleus, so it cannot exist. So we have, if we go through the energy, we have found it will be greater than, in some cases equal to 10 MeV, in some cases greater than 10 MeV. So it shows that if electron is to be existing inside the nucleus, it must have an energy which is 10 MeV. But from the experimental data, we know that an atom as a whole, it cannot have an energy greater than 4 MeV. As a whole, it cannot have energy greater than 4 MeV. Now the electron itself, it has got 10 MeV if it has to be inside the nucleus. So there is a vast difference, 4 MeV, 10 MeV, it can be more than that also. So what does it conclude? What does it mean? We can conclude it as the electron cannot exist inside the nucleus. So these are the two point of views from which we can say that electron can never exist inside the nucleus. There may be many things, I don't know, but these are the two ways of thinking or to understand that the electron cannot exist inside the nucleus of an atom. Thank you. So if you have liked the video, just like my video, share my video, subscribe my channel. Thank you.